All right, everybody. Hope you're having a great day. We're going to get right into today's lesson. So it's all about graphing and systems and kind of what our answers, our solutions mean. So good news for us. We've seen graphing before, right? We did a little bit of that when we figured out if these systems had infinite solutions or no solutions or one solution. So today we're going to dive back into that and work on graphing. But more importantly, too, what do these solutions mean in terms of these two equations? So for starters, we've got a couple words. Just remind ourselves about rate of change and slope. So we can say rate of change. This is just a ratio or a number between our change in y and x, right? So it's a ratio between, I'll say, the change in x and y. And that rate of change is just a number. Just like slope is a number, right? These are kind of synonyms for each other. Slope, just the steepness of a line. Okay? So let's take a look at what we have over here. So it says the given equations are graphed to the right, and then here's two equations, and they're both in standard form. That's lovely. And it says, what are the coordinates of the point of intersection? Well, it looks like this is a one solution, and it looks like that point right there, which I will say is at 3, -1. So here, I should probably write that over here. 3, -1 is where they intersect, and that's the solution. Here it says substitute the coordinates into each equation and describe the results. So the first equation we have is x plus y equals 2. Remember, in an ordered pair, you have an x value and a y value. The x is always first, the y is always second. So if I take x plus y equals 2 and I substitute in everywhere I see an x, I plug in a 3. Everywhere I see a y, I plug in -1. I get those from the ordered pair. Is 3, let's see, 3 plus -1, that's a tough one. I think it's 2, though. Is 2 equal to 2? Of course it is, right? That's a true statement. So there's our first equation. Let's see if this works in the second equation. So x minus y equals 4. Again, x is 3 minus y is -1. So 3 minus -1, that's a double negative. That's the same as 3 plus 1, which is 4. So once again, 4 is, of course, still equal to 4. So that's how I can check with a little bit of algebra that this, ordered pair, 3 -1, is indeed an answer. Here's another one here. Again, if you want to try this one on your own, go right ahead. If not, we're going to work on this together. I'd say the solution to this system is right here. So what's that ordered pair? That's the ordered pair 2, 1. All right, again, remember, there's always an x and a y value. X is always the first number. If we substitute those back in to our equation, so 2x minus y equals 3. So 2 times 2 minus 1, does that equal 3? Well, that's 4 minus 1. Yeah, that's 3. Okay, so that works out to be true. Let's see if the other equation works. All right, x plus 2y equals 4. X is 2, y is 1. So this is 2 plus 2 times 1, which is 2, so that's 4. And, yep, that works out too. So question 3, a thinking question. What can you conclude about the coordinates of the point of intersection of two linear equations? So I would say the coordinates, right, which is that x and y ordered pair, solve both equations Okay, good enough. All right, great. Let's move on to the next page. Okay, so we're still going to study systems of linear equations in two variables. That's not changing. Here are two equations that form a, again, we're just working on, they form a system of linear equations. Why do we call them linear equations? Well, because when we graph them, they are linear or they make straight lines. Right? So we call these a system of linear equations, or we simply put, we call these a system, right? This is, again, this isn't anything new. We've talked about this. The solution, okay, of a system is that ordered pair, right, that solves each equation in the system, right? Provides a solution to each equation. So, okay, example 1, it says the graph at the right shows the two equations below. Identify the solution, then check the solution algebraically, right? So here is the solution right here. So this is at the ordered pair 2, -1. And let's see if it really does work out. So 3x plus 2y equals 4. If we substitute 2 and -1, where they go? 2 being an x value, so 2 goes here. Y is -1. Let's see what happens. 3 times 2 is 6. We're going to add that to 2 times -1, which is -2. Does that equal 4? It sure does. Yeah, 4 happens to equal 4. So we can't stop there. We know it works out in the first equation. Let's see if it works in the second equation. Right, this is -x plus 3y equal to -5. Once again, plug in 2 where you see your x. So this is negative, you can think of this as -1x, so -1 times 2. Plus 3y, so 3 times -1. Does that equal -5? So -2 plus -3. Yes, I believe that does add up to -5. All right, so this one works out just fine. All right, we've got another one here. If you want to try this one out and see, does this solution right here, this ordered pair, which I'll say is 3, -3, does that work in both of these? So go ahead and give it a pause and you can check it out. So here we go. All right, so y equals 3x minus 12. So in this case, y is -3 and x is 3. So 3 times 3 is 9. Minus 12. Yeah, 9 minus 12 is -3. So, yep, this one works. Let's check out the next one. Y equals -2x plus 3. Again, our y is -3. Our x is 3. All right, so -3, is that equal to, this would be -6 plus 3. All right, -6 plus 3, yep, still -3. So this one works out too. Okay, so here's the next part of what we're going to do. This part won't be new, right? This is solving a system by graphing. So here's our 4 steps. Step 1 and 2 we've done before. So is our equation in y equals mx plus b form? That's step 1. Once it's there, we can go ahead and graph it, right, using our slope and y-intercept. Step 3, this is where hopefully we've got 2 intersecting lines. We'll identify our solution. And now we know step 4, that's what we've been working on, right? We can figure out, is this really a solution? So again, at any point in time, if you want to try these on your own, you just pause the video and go right ahead. In the meantime, we're going to graph these two. Neither one of these is in graphing form, so I'll work on x plus y equals negative 2. Okay, x, we need to subtract an x from both sides. Now it's ready to graph. Y equals negative 2 minus, and I'm just going to put 1x. Ooh, didn't write very well. Okay, so let's go ahead and graph that. So this has a y-intercept of negative 2, and this has a slope of negative 1. Okay, so negative 1, I could go down 1 and to the right 1. Down 1 and to the right 1. We've got enough points for a line, so let's go ahead and make a super straight line. Alright, that's not super straight, but okay. Let's graph the next equation. 2x minus 3y equals negative 9. First things first, let's move 2x over here to the right, so we're going to subtract 2x from both sides. Be careful, the 3y really has a negative sign that's with it. Divide by negative 3. Watch your signs. If you get them backwards, you might have your slope or your y-intercept backwards. Negative 9 divided by negative 3, positive 3. Negative 2 divided by negative 3 is a positive. There's your slope. Okay, so y-intercept here, positive 3. This one has a slope of positive 2/3. So I can go up 2 and over 3. When you go over 3, you got to go over the right way. I could have also went down 2 and over 3. Okay, bam, there we are. I believe our solution is right here. This is at the ordered pair negative 3, 1. Alright, if we wanted to go ahead and check that, we could. But I believe it'll work out just fine for us. Okay, let's graph this next one here. Again, neither of these are in graphic form, so I'll take care of 3x plus y equals 11. Only thing I need to do really is just move 3x over. It's a positive 3x, so we're going to subtract 3x. So now it's y equals 11 minus 3x. Okay, so this has a y-intercept of 11. Okay, and so we'll see that 11 is not on our graph. Our graph only goes to 6. So what I've done here, like magic, is make a table. So when this happens, and it doesn't happen very often, we make a table and we can just pick whatever numbers we want, right? I know if x is 0, y is 11, right? If x is 3, okay, like we see over here, if x is 3, y is 2. All I did was take 11 minus whatever 3 times my x number is, right? 3 times 3 is 9, so 11 minus 9 is 2. So now I've got a couple points that I can plot. So 3 and 2, right about here, 4 and negative 1. All right, so now we've got a couple points that we can plot. So, all right, perfect. Let's work on the other equation. This is x minus 2y equal to 6. So again, we've got to move x over, so we'll subtract x. Negative 2y equals 6 minus, you can think of that as a 1x. Divide by your coefficient in front of y, so negative 2. Watch your signs, and we're almost done. So 6 divided by negative 2, negative 3. And this is a negative 1 divided by a negative 2, so that's a positive 1/2 x. So we've got a y-intercept of negative 3, and I have a slope of positive 1/2, so up 1 over 2. Right, up 1 over 2. There we go. So easy to see. Here's our intersection right here where the two meet. This is at 4, negative 1. All right, go ahead, pause the video. Why don't you guys give this last one a shot? All right, see what you can do. Again, remember, solve for y and then graph them. Okay, go ahead and do that. Okay, so here you go. Looks like these two intersect at the point -1, 0. All right, again, there's both of our equations there. And let's move on to our next page. I think we're getting closer to being done. All right, last page here. So now we've got to do a little bit of what we were doing yesterday. And then once I get done with that, then I've got to graph it. And I'm really mean. I didn't give us a graph that's already labeled, so we're going to have to label our graph, and I'll help you with that. But we're comparing a membership at two different health clubs. Here's our first one, Club 1. There's currently 400 members, and membership is increasing at a rate of 25 people per month. Rate of change, right? It's changing at a rate of 25 people per month. We're starting with some initial quantity, 400, and we're changing 25 people every month. So if we were going to write an equation for that scenario for Club 1, right, I would say we're changing at 25 people every month, and we have 400 people to begin with. What about Club number 2? Currently 200 members, right, and we're increasing at a rate of 50 people per month. So per is your rate of change, 50 per month. All right, and we start with 200. Again, so X is the number of people, the number of months that go by, and Y is the total number of members that we have in our gym. So let's look real quick here at our graph, and let's get some stuff labeled over here. On our x-axis, I would say this should be in months. Okay, right, this is time, right, 0 months, 1 month, 2. And let's let every 2 squares be 1 month. So here's 1, and here's 2, and here's 3, and 4. All right, I think that'll be good. Obviously, here is 0. 7 would be over here. And then for our Y, obviously that's members. And again, let's let every 2 squares be, I don't know, how about 100 members? That sounds like a reasonable amount. So here's 200 and 300 and 400. All right, 600 and 700 up here. Okay. So let's graph these two now. Again, if you want to graph them without me, you can do that. If you'd rather wait, that is okay too. I'll graph the first one here, 25x plus 400. So we're going to start right here at 400. And then we're changing, right, 25 people for every one month. All right, so now think about it. So if our squares go up by 100, that means every square is worth 50. So for me to change by 50 people, really, that takes me 2 months. So if I go up 1 square, 50 people, then I have to go over 2 months, right? So I could go up 1 square and over, we've got to go over to 2 months. So that's going to be all the way over here. All right, and that should give me enough. And we can, if you want to continue that pattern, it's constant, you could do that. So you could go up 1 square and then over 2 months. So up another 50 people takes me 2 more months. Up another 50 people takes me 2 more months. All right, so hopefully your ruler is a little bit straighter than my hand-drawn line. The next one I think is a little bit easier to graph. Again, changes by 50 people every month. So let's see. This one starts at 200. All right, so we're going to start right about here. And then changes by 50 people every month, right? So it's going to go up 1 square, over 2 squares, right? 2 squares in this case is 1 month. Then it will go up 1 square, another 50 people over 2. All right, and it's going to keep this pattern I'm gonna say that one looks about like that. Okay, so that's pretty good. And let's see what it wants to know. It says predict when the membership at both health clubs will be the same. So in other words, when will they have the same number of people? Well, gee, if I would have picked a better, graph and made instead of every 2 squares be 1 month, I think we would have seen that. But I don't know. So if we're at 7 months right here, and so 7 months is here, 8 months is probably over here, right? I'd say that's pretty good. And how many people do we think that would be? So at 8 months, I don't know, maybe somewhere around here. Again, you got to think my lines aren't very straight. So I don't know, maybe 600 people. So 8 months and 600. All right, we could absolutely check our answer, right, doing what we've done before. So 8 is an x value, 600 is y, and I can plug those in. So since I'm in blue, I'll stay with the blue equation here. So 50x plus 200. So let's take 50 times 8. Add 200 to that and see if we actually do get 600. I think we actually do. It was a pretty good guess. 400 plus 200 is indeed 600. So that one checks out here. I'm betting it probably works in the other one too. This is, again, 600 equals 25 times 8 plus 400. So 25 times 8 is 200. And yep, of course 600 is still equal to 600. Okay, so that was good. We're going to give 2 and 3 a shot, right? If you want to, though, I know we're running a little bit short on time here. If you want to pause the video, give it your best shot on A and B. In terms of writing them and solving them. Again, on this next one, I would say, why don't you use, let's see, 1, 2, 3, 4. Let's say every square here, this is going to be years when we graph. And why don't we say that right there would be 5 years. And then 1, 2, 3, 4, right here would be 10. All right, and that should be good. On our y-axis, this is going to be number of students. So this is students. And let's say each square is worth, I don't know, how about 400 students? So like right here would be 1,200. All right, right here is 2,400, right? And that can keep going up every 3. This would be 3,600. All right, 4,800. Okay, so let's use that. If you went up another 3, what is that? 6,000. So the very top here is 6,000. Again, make your graph nice and neat. Okay, so that'll get you going on that one. And as far as your graph on this one down here, I would say we can probably label this one the same as well. Every square down here, again, this is also going to be years. So, right, I could say here's 5 years, here's 10 years. We're going to deal with money on this one instead. All right, but I still think $400 is a good, right, here's 0, so this would be 400. I'm sorry, I just lied to you. Terrible. Okay, 1,200. Every square is 400. So if we're 3 squares up, this is 1,200. And then we go another 3, and now it's 2,400. Perfect. All right, so this is 4,800, and the top of my graph is 6,000. Okay, so when you come back, all right, I'll have everything filled in here for these, and you can see how you did. Our homework for tonight, right, not any writing. It's just going to be these 2 pages over here. So solving systems by graphing. So you're going to have this one, and then you're going to have this one. So sounds good. Anyway, let's see how we do with these. And pause the video. When you come back, everything will be right there for you to take a look at. Okay, here we go. So here's what we got for the last 2 graphs. Again, using a ruler will produce much more straighter lines than what I've given you here. So make sure you use a ruler. I know some of the slopes are hard to graph on here, but that's kind of what we're going to deal with. You know, we're not going to get nice, hey, up 2 over 1. We're going to have to think about these a little bit and say, okay, hey, if I go up $100, let's see, that's got to be 4 months, right? So up, you know, $400 takes me this many months, that sort of thing. So good practice for us there. Our homework tonight, though, luckily doesn't have anything to do with crazy graphs like this. So hopefully it's all good. But 1 through 7 is your homework. You see it right there. So you guys can go ahead and get going on that. But have a great day, and I'll see you guys tomorrow. Later.